All right, class, this is going to be a video of me working out these 5 identities per your request. Just make sure, try these before you watch the video, right? Because if you watch them or watch the video and you're like, oh yeah, I'm getting this, yep, it's really hard to kind of come up with these proofs or verifications on your own. So yeah, give it a shot and then come back to the video. Okay, so I'm going to start with 1. And 1 says 1 minus cosine squared x times 1 plus cotangent squared x equals 1. So honestly, when I first looked at this, I really wanted to FOIL it. And I did. And I saw it was getting worse and worse and worse. So I went back to the drawing board and I was like, wait a minute. I think actually 1 minus cosine squared x equals something. So I'm going to mess with the left side first because it's messier. And what do we get? Well, we end up getting, if we replace 1 minus cosine squared x, we can replace that with sine squared x. That's from that identity sheet. And this one you might not know off the top of your head as easily as that the 1 minus cosine squared x, but this is equivalent to cosecant x, or cosecant squared. And so what I can end up doing, and let me actually just make this look a little bit better. I'm going to put it over here just to get you guys into good habits. And then, well, cosecant squared is equivalent to 1 over sine squared. And then this guy's over 1, so these reduce out, and what do you know? We get 1. And again, it's good habit to rewrite what you started with. So again, you want to try something that comes to mind. You don't want to keep going down this path, though, if it gets worse and worse and worse, and you don't want to give up this attempt. No, throw it in the trash and go back to the drawing board. All right, so for 2, this one says tangent squared theta cosine squared theta plus cotangent squared theta. Oh, sorry for that noise. I'm praying my dog doesn't bark, and I can't believe it, he didn't. Okay, so clearly I need to mess with that left side because it's messier. So just like what I'm doing, you have to do on your exam, write every step out. So tell me which side you are starting to manipulate. Okay, the fact that this is in terms of cosine and this is in terms of sine, that's my indicator that I am going to try, my first attempt is going to replace tangent squared and cotangent squared with sine and cosine. So the definition of tangent squared is sine squared over cosine squared. And that's multiplied by cosine squared. And then cotangent squared is cosine squared over sine squared. And I'm going to run out of space. I'm going to move this up. So then I can multiply by sine squared. And these are over 1. And this feels really good because this is like the indicator you're on the right track because things are starting to reduce out. Oh my goodness. And so we end up getting sine squared theta. Don't forget your input. Cosine squared theta. And we already proved that is equal to 1. So we don't have to prove it again. And then again, good habit, so you can get full credit when you're showing your work. Rewrite what you started with. All right. Moving on to 3. This one says sine x plus cosine x over cosine x minus sine x minus cosine x over sine x. And that equals secant x cosecant x. All right, hopefully it's clear. It's the left side you want to mess with because it's messier. All right. Now I will say, so many of us want to go ahead and say, oop, that's gone, that's gone. Oh, sorry, I did the wrong one. That's gone. No, 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 no. I'm going to scream at you. Make sure it sits in your brain. This, you cannot reduce those out. Those are terms, all right? You can only reduce factors. And what I mean by that is you can only reduce things that are being multiplied because that's how things reduce. You know, 1 plus 3 over 3 does not reduce to 1, all right? So you cannot reduce that way. The fact that I have, here's the strategy, you have 2 terms, okay? But what our goal is for it to equal 1 term. And that is your huge indicator that you need to find a common denominator. And so I'm just going to save myself a little time and show that I'm going to multiply this top and bottom by sine x and this top and bottom by cosine x, just to save my hand a little time. All right, I'm going to run out of room, so I'm going to have to go down here. So, okay, I get, now, this is multiplied by this whole thing. This is multiplied by this whole thing. So I get sine x squared, because I'm going to distribute it, plus sine x cosine x. Now be careful with this negative. So now this is negative cosine x sine x. And this is a negative times a negative, so it's a positive cosine squared x. Be careful of those. They're usually the thing that messed me up as well. Well, what happens here is these go away because they're the same exact thing, and one's positive and one's negative. And what is this thing equal to? Starting to feel good, 1. And so I get 1 over cosine x sine x. And let's refresh our memory. What is our end goal here? I'm trying to get to secant x cosecant x. So, oh, I think I'm going to get there. This 1 over, let me just write it this way to convince you. You would not have to show this step if it sits well with you already, but it is nice. 1 over cosine x is secant x, and 1 over sine x is cosecant x. And so, let me zoom out to refresh my memory what we started with. Sine x plus cosine x over cosine x minus sine x minus cosine x over sine x does in fact equal secant x cosecant x. So hopefully these are getting better for you. All right, we have 2 more. 4. There's sine t times cosecant, now this is a fancy one, pi over 2 minus t, and this is going to equal tangent t. So again, I'm going to start manipulating the left side, just because it's more involved than the right side. Now, this is a blast from the past. This thing right here is known as a cofunction. You learned this in Unit 5. That is equivalent to secant. Remember your cofunctions, like sine of 30 degrees was the same thing as cosine of 60 degrees. So it was that idea of those complementary angles, they will equal the same thing. And so what I get here then is, well, if I know I want to end up with tangent, well, maybe I put secant in terms of cosine and sine. So that's 1 over sine. Oh, forgive me. That is not true. It's 1 over cosine. And then so we end up getting sine t over cosine t, which is in fact tangent. Again, I'm going to rewrite this. So, you know, this might have been hard for you to like recognize because, you know, you saw it a long time ago, and honestly, it hasn't shown up in this class all that often. It's cool if you recognize it, and, you know, everything we learn in here, I'm hoping you retain. But remember, you have a choice on your exam. So, you know, if you look at that and you're like, I do not recognize that, then, you know, you want to choose another one. And that is life, right? We're not going to retain absolutely everything, even though in an ideal world I would like you to. But all right, so for our last guy, it says the square root of 1 plus sine x over 1 minus sine x. And we want it to equal 1 plus sine x over the absolute value of cosine x. I'll explain that absolute value at the end. Okay, these kind of look equivalent, like, you know, messy-wise, but this really, because it's a square root, I'm going to deal with that one. So I'm going to take this side, show the reader, aka me, what you're messing with. All right, this is what gives this away for me. I have to somehow turn this denominator into this. And that is why knowing that Pythagorean theorem identity is so useful in these. Because, well, if I multiply, ooh, that is a rough square root. If I multiply by the conjugate of the denominator, and this is similar to what we did in the notes, then I might be able to get out something that's on my identity list. And again, this just comes with practice to recognize that. So that numerator, you can FOIL it out. Excuse me, it should be like this. I know, though, to not FOIL it out because somehow I have a square root here, and then I don't have one here. So I want that to go away. So if I keep things in the squared form, possibly they can go away. If I do FOIL the bottom, because that's not a perfect square, so I can't leave it like that numerator, I get 1 minus sine squared. And hopefully it's getting a little bit better for you. I recognize that that bottom is equivalent to cosine squared. Well, now that is really great news because now they're in perfect squares. So if you took the square root, it would just be 1 plus sine x over cosine x. I'm okay. Well, let me just do this real quick. Let me rewrite what we started with. Good habits. All right. Now, the reason they had to put the absolute value here is because it doesn't work if cosine is negative. I would never take that off for you just because we haven't talked about like looking into that. So you can absolutely, you know, just throw that on there. And again, the reason is because, you know, this piece, so let me look here. Let me just explain this a little bit more. If you're interested, if you're not, you can stop me now. But 1 plus sine x will always be positive. All right, there's no way it won't be because 1 is the biggest that sine can be. So that numerator will always be positive. Now this piece is not always going to be positive. And I can't take a square root of a negative. And so that's why we had to say, nope, I got to make sure it's definitely the absolute value. Again, I'm not going to be testing you on that, just so you know. Okay, reach out if you have any questions. Best of luck on your exam, and I'm around. All right.